one type of function that we're going to work with a lot is linear functions. That's one type of function that comes up a lot in calculus. So let's look at an example of a linear function. And I have to admit the context is a little outdated, but it used to be in the time of landlines that the cost of your monthly phone bill consisted of a basic charge plus you had to pay for every minute of long distance. Yeah, so let's look at this situation. And so you have your basic charge of $30, and then every minute you're talking costs 10 cents. And that gives us a relationship between time in minutes and cost in dollars. So this was time. So our input is time, our output is cost. So T is measured in minutes, cost is measured in time, and now we can figure out what your phone bill is if you are talking not at all, or 30 minutes, or 60 minutes, or 90 minutes, and so on. So if you're not talking at all, you still have to pay your basic charge. So that's $30 that you're paying. Now, if you are talking 30 minutes, then that costs you 10 cents for each minute. So 30 minutes times 0.1 dollar per minute, that turns out to be $3. So you have to pay $33. So it seems like it's $3 for 30 minutes of talk time. We can use that to fill in the rest of this table. So if we are talking for 60 minutes, it's going to cost us an extra $6. So we have for a total bill of 36, and then 39, 42, and 45. So what I just did in my head, like every 30 minutes costs $3, no matter if it was the difference between 0 and 30, or 30 and 60, or 60 and 90. And so we can also use that fact to draw our line and make our life easy, to draw the graph of this function. So we have time right here, T in minutes, and then we have cost right here in dollars. And we know the numbers for 0, 30, 60, 90, 120, and $150. So I can label my horizontal axis. And output values that are interesting, the highest one is 45, so I'm going to put like increments of 15. So let's say this is 15, this is 30, this is 45. So when t is equal to 0, we are not owing anything. We owe $30. We still owe $30. And when we talk for 150 minutes, we owe 45. So that is about here. And then I can put in all the other values in between, and they will all lie on this line right here that connects the two dots, because every minute costs me exactly the same amount. So I could have drawn the dots first, but they would all lie on this line right here. And so here's the graph of my function. Now, in the work that we just did, we basically computed the average rate of change of c over any time interval, because the average rate of change, our formula, if you remember, is the change in output over the change in input. And for our first time interval, for example, what was the change in cost? It is going up to our table right here. We have a time interval from 0 to 30, and our cost increased by 3. And over the next time interval, it also increased by 3. And we had, again, 30 minutes of time change. So the same thing happens for any of our time intervals. We are always adding $3. So the change in cost, I can write it down for one of them specifically. 33 minus 30, that's where that first plus 3 came from. That's our change in cost. And the time interval was 30 minus 0. I could have used any other one. And so what happens here is I have to spend $3 per 30 minutes of talk time. That's my average rate of change formula. And it gives me the cost of talking per minute. So $3 divided by 30 minutes, that is $0.10 per minute. So our rate of change is actually the per minute charge of calling. In our phone bill. Now we can also find a formula for the cost. Oh, and before I go away from this, also the rate of change is the slope of our line. So the slope is $0.1 per minute. We can find a formula for our cost function. And if we go back to the table, what we did is we start when t is equal to 0, we are owing $30 no matter what happens, right? No matter how much we talk, we owe $30. And then depending on how much I'm talking, my price goes up. And so the price was $0.10 per minute, and then times the number of minutes talked. But we have a variable for that. So if we just put this in terms of our variable right here, this is what we call t, our variable t. And so our formula is 30 plus 0.10t. And that is our answer. So this is our formula for our linear function. Now we can use that formula to answer questions like the following. If your bill is $135, how long did you talk long distance? Okay, so the cost is equal to 135, and the question is, what is the value of t that gave me that outrageous phone bill? Let's use our formula. C is equal to 135, and that is 30 plus 0.10 times t. And now I can solve for t. And the way I do this is I first subtract the 30 from both sides. So when I do that, I get 135 minus 30. That is 105. So I subtract 30 from both sides. That gets rid of the 30 right there on the right hand side, and I'm left with 0.10 times t. And next, I'm going to divide by both sides by 0.10. So I divide by 0.10, and that gives me 1050 for our value of t. So that's a lot of talking. So this means that I talked for 1050 minutes. Long distance. That's about 17 hours and 30 minutes. But it's over the span of a month, so I guess that's not that bad. So here we've seen an example of a linear function. So all of this is a linear function, and we can see that the formula is of the form of a particular form. So we have this 30, and then we have our rate of change right here times our variable. So keep that in mind. In our case, we have our output, C, is equal to a constant, plus our rate of change times our input variable t.